right, here we go. Just checking to make sure everything works. We will get started in a moment. Gotta watch a Twitch advertisement first. Okay. And gotta put away the cat. Okay, I think this is working. Okay, ready to begin. As soon as I know that audio is working. There we go. So, if you were with us last time, this is the making of a game in Corona SDK. I'm making a game from start to finish, and yeah, every session is Fridays, hopefully a little earlier than I started today, but you know, life gets in the way. Check out Twitter to know when I am starting, which actually I need to post right now. As a note, I just pushed all this stuff up to Git, so if you're just joining us now but don't have the code, go to git TylerMakes/Bulbasaur. As mentioned, I name all of my projects after Pokemon so that it's a name that I can't use in production and I have to come up with something clever when I actually release. So you should do that as well. So I'm just posting on Twitter, so if anybody's watching, they know. Cool. All right. So where we left off was that we can click anywhere and our little square will go to it. It goes very slowly right now because I was testing something. So what I talked about was that I had expected it to, when we chose a place, it would start here and then it would ping pong back and forth on either side of it. And then I wasn't sure why it wasn't doing that, and that's where we left off. That's because I didn't look closely at the code that I was writing. And the reason is that normally when I've started an app like this or something, I would have done else ifs here, which I think that's the right one for Lua. I might have to look that up. I can never remember Lua syntax. But anyway, this would be an else if, which would mean that like in one iteration it would be behind the dot that it's supposed to be at, and then the next iteration it would be above the dot it's supposed to be at, and then it would ping pong back and forth. However, this last time that I did it, I did not do that. And the result was that if it was greater than, or let's say it was less than the destination X, it would add the move speed. And then if it was greater than, what would happen on, so what would happen is it's less, we add the move speed, now it's greater than, and then we subtract it. And so it would, before this it would have moved back to its original position. So you'll notice that it's always behind the red dot. Like it won't stop over here ahead of the red dot. It'll always keep moving until it moves behind the red dot. In this case, it's like almost right on it, because remember we're starting with the top left X and Y position. Anyway, so let's make it so that it moves much quicker. Actually, I don't even know if we need that anymore. You just let it go super fast. Yeah, look at that. Yeah, so as an example, we're going to add an else if. Yeah. Now with this, see, you can see it ping-ponging back and forth. Because on one iteration it's ahead and one iteration it's behind. Anyway, it's actually better this way, where it doesn't ping pong. At least it's like stable, even if it's behind. Ooh, maybe we should give that a little space so that we can watch it run over to a new location. Anyway, so that was to handle touch input and frame events. Today I'm going to show you how the class function works that I use. It's pretty basic. Doesn't have a lot of fancy bells and whistles, but it makes for a simple structure that is familiar if you come from other object-oriented programming languages, and also it's very similar to the Corona SDK libraries, so it makes it feel more natural. So what we're going to start with is we are going to make a grid of tiles that take up a good chunk of our screen. So let's go ahead and add a tile class. Oh, that's not tile. Also, we're going to preface these with bulb for Bulbasaur, because as I mentioned before, if you ever want to be able to mix code from one project to another, it's nice when they're all prefixed like this. In other languages you have nice, well, and in this you kind of technically have a namespace based on, you know, the directory structure, but still that can be problematic. So for now I'm just going to do that. If we find a reason not to later, you can always change it. So whenever I start a class, the class has this basic layout, which I'm going to show you. Again, this is pulling from a project I had put up before. So we're going to call this bulb tile. Ooh. And yeah, this is a basic class. So I'm not going to go through all the details of this unless somebody eventually gets on the stream or contacts me on YouTube or whatever and wants me to explain this. It's very helpful to go through and understand all of this and how it works, but it's not really necessary for what we're doing right now. Like I've said before, I want this to just be, here's how I go about making a game, and while I do know how this structure works, I don't have to think about it when making a game. The only time I had to think about it was when I was trying to do some fancier inheritance, which is not kind of like baked into this system. And if we end up coming across something like that, I will teach you how to do it. So anyway, here's this instantiates the class, and what this does is it makes it so that elsewhere I can do something like this to create the class, or an instance of the class. So here's bulb. Oh man, if I can't type bulb, that's going to make things problematic. And the idea is that you have a function here that just takes the parameters from here on. This C is actually the way it references the actual class itself. So maybe I will get into a little bit of how this works, just for clarity's sake. This base is, of course, this C, which is the class that we're creating, and then it has an init function, which is what we're ultimately going to be calling here. So yeah, anyway, this C is the class that we're building, this new class instance. And so when we do things like C.I, that is basically putting a member variable on this class. So to explain, what happens is, this is like the values I, J, X, Y, or whatever. Let's say we just have our X and our Y. And let's say this first one is 0, 1. Normally it'd be 0, 0, but I'm putting a 1 so that you can know the distinction. So now if I went tile.x, and let's say this, let's change this code here so it looks like this. So if we had, x, y, let's get rid of all these other things, and I wanted to just do this, print tile.x, print tile.y, this would print out 0, and this would print out 1. Because, this class returns this object within it that has this function, etc., etc. But basically, all you need to understand is that this C in this first function refers to the object that we have, which is tile, the one that we're creating. And everything past the C is parameters on that object. And so when we put those values in, they go ahead and set them on here. Now, that's the basis of it. The reason I'm going to have these other values, this I, J, X, Y, and size, is that I and J is going to be its location in the grid, and X, Y is going to be its actual X and Y location on the screen. So let's say I have, and there's ways that we could do this by calculating it, but I don't want to calculate it all the time. So we have a location that's 0, 1, followed by a location 0, 2, or whatever. These are two blocks that are right next to each other. So on our screen, we might have a block here and then a block right next to it. Those are at 0, 1, 0, 2, but their actual X and Y locations might be, 100. Well, actually, so this is X is the first one, Y is the second one. So let's say that it's at 100 is where the X is, and then the Y is at 100, and then the next one it's 100 and 200, because these are 100 by 100 blocks. So that's why we're going to have an I and a J, and as well as the X and Y. So let's do that. The tile view is actually going to be the graphical representation. Initially, I'm going to just draw rectangles with different colors. Eventually, I'll show you how to do sprites. And open is not relevant in this context. So there we go. So it's grid location, IJ, XY is its real pixel location. Size is self-explanatory. And then view will eventually be the graphic. This require class imports this class method so that we can actually do this, right? So sorry, I'm just looking at this class just to see if there's anything I actually want to explain. It'd take me a minute to go through all this and then explain how it works, so I am not going to do that. Because as I mentioned, I don't think it's relevant for right now. So in our previous code, we had all this fancy enter frame stuff and moved around a character, etc., etc. We had a touch and stuff. We're going to get rid of a lot of that. I'm going to comment out most of it, and I'm going to delete other portions. Actually, let's just comment it out for now. We'll get to adding all this stuff back later in a very different form. But yeah, so we're going to have tiles, and they're going to be in a map. So I'm actually going to create the map as well now. We could have just started creating the tiles straight from there, but I prefer to kind of like follow good practice and build some of our structures that we know that we're going to have as we're going. Let's go make this a map. We don't have an I or a J, but we do have its X and Y location. Let's leave it at that for right now. We'll see if we need more in a bit. Actually, yeah, let's just give it with the height, rows and columns. I'm going off some code I did before. So it is funny. So the whole point of this is to teach you, how somebody goes about thinking about problems and development, because I find it's very helpful to see another developer just code, just see how they do it and follow their thought patterns. There's a concept, I think it's called katas, and it comes from like Japanese and martial arts training, and the premise that you just follow a series of steps that are set out by a previous master, and by following those things you kind of get the muscle memory for what you're supposed to do, and then eventually you learn why and how to do it especially well. So that's one of those things, is I even leverage my own code whenever I write something new. For instance, things like this map, things that I've worked out why I want them to be a certain way before. I may not remember why, but I trust my past self unless I find a good reason to change it. So anyway, what we're doing here is we're going to have the width and height of the actual space that we want to put our grid, and then we're going to have a set of rows and columns, and the tile size is going to just be the height divided by the rows. So the premise being that we're going to have a bunch of rows. We're going to divide the height by the number of rows. So let's say I wanted it to start right here, and then I wanted 5 rows. We'd divide that area into 5, and then that would be the size. And then the reason there's only that tile size for height is because we want square tiles. So we're going to do that for the rows, and then we're just going to make that the size of the columns. And then we'll see later about how we're going to do columns. I'm probably going to base them, base the number off of how many we can actually fit, based on what space there is, but we'll get to that later. Maybe we'll do it manually, I don't know, we'll see. Anyway, we're going to need the class, and then obviously this map is going to need tiles, so it's going to need to import the tile code. Oh, nope. That was the name of the other project. And as you can see, if I wanted to mix these Bulbasaur tiles with my Pika app, it would be nice if they were named differently. Also, I just noticed that I don't think that these are saving in the right place. Give me 1 second to move these over to the correct folder. This is what I get for messing around in different projects. Looks like we might have somebody on the stream. Be awesome if people eventually are watching this live and can jump in on the chat and ask questions, and I can answer stuff while I go about arranging things. That's my eventual goal, is to have regular stream followers who can help guide where this project is going to go, because I want a good portion of it to be affected by what people need to learn, what they want to learn, what they don't understand. But a critical part of this, like the most important part to me, is making an actual game. Like I said, too many tutorials I don't think go far enough in actually creating something from start to finish, and so people learn the bad habit of doing little projects and little pieces and learning little things and never actually making a full-fledged project. Oh, interesting. The map got saved to the right place, but not the tile. Anyway, so there we go. Tile and map. Back in our project folder where we want them. Okay. So, let's go start making our map. So, of course, here we're going to need our map. Close our map, and let's go create a basic map. What I'm gonna do is actually oh yeah, another thing that I like to do, which I forgot to mention, I just remembered, I like to make an overarching game class, and this keeps everything nice wrapped up in this one game, which means that like I said, in other apps I've done cool things where I've taken an entire game and put it inside a different game, and the results can be kind of cool. Because you can do fancy stuff like making like a mini game inside another game that's based out of something you've built before. So like I said, we always have this class that we're importing. Make sure we've got it. Got the main game. We're gonna have a width and a height. Ignore map. We're gonna have a map, or we're gonna ignore mode. We're gonna have a map and a player. Some of these things will come back into play later, but here we go. So we have our base game, which just has a width, a height, a map, and a player eventually. So we're going to start by creating that, and we want to be able to actually delete that map once we've built it. So, or the whole game. So we're going to do local game, so we have access to it. It's basically public and global. And then we're going to make our game. Yeah. We need to give it a width and height. In this case, we're going to use the full contents width and height. Basically the space we have on our screen here. And now if you look at the config, this is going to be our width and our height that we're going to use, and that's actually going to stretch, but we're going to be referring to it as that. As you'll see, I tend to make all of the width and height arrangements like based off this. They're proportions of this, as opposed to actually doing any actual numbers, because that way you never have to worry about accidentally screwing up something that should scale to the proper width and height. In this case it would be fine because we're actually going to let Corona do the scaling, but if we took off the scaling, that would screw things up. So you'll see that as we go along, how I do handle widths and heights, but for now you don't have to worry about it. Okay, so we just have our game object, which we're going to create. It's going to fail. 43. What are we looking at? Oh, yep. We've got to add it, of course. There, it's fine. It's doing nothing. Let's just make sure that everything's working as we expect. Hey, there it is. We're printing. That lets us know that we're actually working. Okay. So what I like to do now, in this initial class, you could theoretically just go ahead and like, start making your map right here. The reason I don't do that is because in this initial class, C is the base class, but in all the rest of our functions, it's going to look like this. I gotta remember syntax. It's been a little while. That's right. Problem with working in too many languages is remembering all the syntax. So here's one of our base functions, and when we're inside this function, we're going to refer to it by using self. I just realized I might want this a little bigger. Maybe that's more visible in the stream, I hope. Maybe a little bit bigger. Yeesh. Hopefully no one has had any problems with that prior, but anyway, I'll just keep it bigger. And yeah, that's probably don't need it that big. Okay, anyway. So yeah, from now on, when we're calling it, it's going to be referred to as self, and that has to do with how Lua handles the way that you call functions, because we'll be calling those functions like this. And I believe, if I remember correctly, because we're using the colon, the technical first parameter that we're passing to this function is the object that called it. Whereas if we just did that, we would call the function with this parameter, and you would not have this hidden self parameter that exists here. So when we do this, it's going to be things like self width. So for instance, we're going to do print and add the width. And that should hopefully fix what we have here. Cool. And see, so it has the width of 1024. So where did that come from? That came from right here in the config, 1024, which is our height. Because this is rotated, that's why we're getting it as a width, I believe, unless I have done something weird. No, yeah, it should be because we're rotating. The width is 1024 because we're landscape mode. But anyway, it comes from there, and then it comes through the display content width, display content height, and we create this bulb game object, which is an instance of this. So it's a brand new object with a width property and a height property and a map and a player, and its width is set to that width. And then when we call game create group, it calls this create, and like I said, it's got the hidden self, which is the object that we created before. That is the one that we were calling it on. So that's where the width comes from. So there you go. That's the basis of how the classes are going to work. And there's very little beyond that we actually are ever going to have to deal with. So there you go. You now know enough to utilize this base class function that I have. Let's see. What was the issue there? Reload. Oh, duh. I don't know why I am typing the wrong things. There we go. So now we've got our map. So yeah, as I was saying, the reason I do this is because in here we're gonna have self.width, right? And we're gonna like, when we make our map, we're going to be doing things like, tile size equals self.width equals self.width divided by 5 or something like that, right? Whereas if we did that up here, we would have to do it with c.width divided by 5. And I don't really like that. Because if you end up wanting to move code around, you have to constantly change back and forth between self.whatever and c.whatever. So I always make a create function that makes that easier. I actually wonder now if I could just call this self, or if that would conflict with anything. Something I might try in the future, a little experiment. But we're going to ignore that for right now, and instead just know that I make a create function that is the create, and it makes it kind of obvious, like when you initialize the object, you just set any parameter or values that you need to at the start, and then this is the explicit create function that creates it and displays it. That's kind of a critical thing. And then I'll also always add a remove self. I would call it remove or something, or well, no, maybe I would call it remove self, but the reason I call it remove self specifically is because that is what Corona calls it, and so I like to keep the same as Corona whenever possible. Just kind of like follow their patterns. And so if there's a self.map, oh yeah, these parentheses, which you'll see me add, are not necessary in Lua, but coming from other languages, I find them comforting, so I always add them, or don't always add them, but I often add them, so you should know that. Noun group. Yeah, so this, you'll see this remove self mirrors what Corona does when you take a visual object and remove it. This is blowing up because this doesn't have a remove self function. We're going to go ahead and add it. Doesn't have anything yet. It will soon. What else is blowing up? 14 expected equals. Oh yeah, there's nothing going on here. Okay, so we are going to start by adding our map. Get rid of that comment. Go ahead and start doing this. Let's give it a set of rows. We're going to go with 15 because that's what I used before and I liked it. As I mentioned, we're going to do the height divided by the rows to decide the size. So along here, we're going to have 15 rows, and then we're going to divide the height by those rows and get the size, and then we're going to use that size to determine how many we have horizontally. So here we go. We're going to go ahead and create our map. Like I said, these this width and height come from here, width, height, and then we have our rows and columns. Okay, for right now, we're just going to say 20 columns. We're going to make that different later, but for now, we're just going to do that. Keep things simple. Actually, no, let's do this. We're going to make a columns value. So we're going to do the width divided by the size, and then we don't want a funky number. We just want the exact number that will fit. So the idea is that let's say there were using this size, we got like 20 here, and then we got a half. Well, we don't want a half of a grid on here. We want only the whole ones. So math.floor will take something that's like 20.5 or whatever, take whatever's after the decimal and get rid of it. So if we were at 20.5, like I said, we would get rid of that, and we're like, hey, now we only have 20. Now, of course, that means that when we draw our tiles, there's going to be half a tile space at the end, but we'll deal with that later. We're not too worried about it right now. Columns, let's spell it correctly. And then, of course, the map is going to have a create, just like the game does. So let's go ahead and add that. And so you can see this structure. I kind of like have nesting all the way down. It'll also appear on the tile, which we can go ahead and add while we're doing this. There we go. So now they all have a create and remove. I am in the habit, which you should probably be as well, of constantly hitting Control Save whenever I make changes, or Command Save, or whatever, depending on your operating system. To constantly save what you're doing, it's a really great habit. Keeps you from losing code often. The other way that keeps you from losing code is pushing it up to GitHub, which is also very important. Plug in real quick. So anyway, I just found out that I had lost a bunch of code on a project I was working on recently, which I may eventually share on the stream or on my YouTube channel. But yeah, do yourself a huge favor and I don't need to listen to that. Do yourself a huge favor and save often. But when you're in Corona and you have it automatically set to relaunch, it's going to complain. So let's get some of these changes done before we go ahead and save again. Or not save, but reload again, because otherwise it's just going to keep complaining. So anyway, we've created our base map. There is nothing there. Let's just go into the map and just show that it's there. We're going to save that. We're going to save that. Oh, you know what? While we're at it, why don't we show what our rows and columns are. Verify that all is honky-dory. Okay. Continue. Oh, did I get it wrong? What is Lua's math library called? Oh, their math library is not capitalized. Okay, there you go. Look, 15 and 20. Turns out that's how many columns we got. Cool. So that was all calculated and nice, great. Now we are going to go about creating some actual tiles. For that, we're going to create a group for the tiles. For now, actually no. So this layers that I've added, you may wonder what that is. Since we're just going to be doing a 2D game system, I want to have different layers so that you can see, like, here's all the grass or something, and here's all like trees on top of it, and here like birds sitting in the trees or something. So that's what this layers is for, and that's going to keep track of some of our graphic stuff. So one of those things is going to keep track of is our group. Groups are a way of connecting visual elements in Corona SDK. You'll see this a lot in almost any graphic system. I'm very familiar with Flash. I'll show some tutorials about how to make art in Flash. You'll see that it uses groups too, and they work in pretty much the exact same fashion, except we're manipulating them with code right now versus manipulating them with, graphical user interface like Flash. Anyway, now we're going to do a loop, and for all of the columns, so Lua is one-based, if you didn't know. If you have a list of items in almost any other language, they are numbered like this. And the reason for the 0 is an efficiency thing with how memory is actually stored physically and referenced, and it creates more efficiency like all throughout systems. It allows you to store more numbers, etc. Because if you have this many digits and you can only have so many items that you can put in these digits, etc. See if I'm doing that right. Maybe I'll get them all. Anyway, this is as much as you can put in. So if you started at 1, oh, this is binary, by the way. If you started at 1, you're not going to be using this 0, 0, 0 for anything. So that's why arrays start at zeros. Or a list is an array is a list is a kind of list. In the dictionary term, like the English term, an array is a kind of list. But in other languages, other programming languages, you'll have an array or you'll have a list or a dictionary, and like these are different ways of housing objects. So anyway, point is we're gonna have this array, and in any other language that array would probably be numbered like this. In Lua, to make it more user-friendly and nice, it's numbered like that. So we're going to start at 1, and we're going to go up to the number of columns. And so we're going to have this, we have this first layer. This is going to be our ground layer. And on that layer, we need to have all of our objects. So we're now going to create another set for housing the entire column, and then we're going to make the rows in that. So this is where you'll see the I and the J come in. Because these are 2 loops, so the idea is, yeah, I'm trying not to teach everything, but I might as well explain while I go along some of what I'm doing. The way a for loop works is I starts out equaling 1, and then whatever the second number is, let's say we put it like 20 instead of self.columns, it's going to go through all this code in between here, and it's going to say, when we first do it, if we went print I, this would print 1, and then let's say there was no other code here. Every time it iterated through, it would just run the same code, print I, and it would print 1, and then it would print 2, and then 3, because this for loop is starting at that number, and each iteration, each time that it passes through the code, it's going to increment it. So it's going to add 1 until it hits the top amount, which is what you've given as the max here. So anyway, that's what we're going to do. So for each of those rows, we're going to create an object that's in this. On this first list, we're going to have a list of other objects, and those in turn are going to become a list of the other objects. Ooh. And this is where we're going to have our tiles. So this is actually an array of arrays of arrays. So you can think of this as our layer with then its rows, and each of those rows has a column, has elements in a column. So if you can think about it like this, like the layer, that first layer 1 is my hand. If I had another layer, it'd be layer 2 right here. And I is the row, so that's each of my fingers. So you can see, or actually technically I is the column in this, what we're doing here. So I is a column, and so for each of those, you have a row. Wait, maybe I'm doing that backwards. Rows and columns get confusing because of the way like X and Y translates and how you have to wrap them. But anyway, yeah, so technically, no, yeah, so it's this way. So, yeah, it's this way. So you have, here's a column. So we're gonna iterate through and we're gonna have our column 1, column 2, column 3. So inside layer 1, I is gonna be 1 and then 2 and then 3. And then J is your actual row element, which is like the digits of my finger. So you have, in this column you have this digit 1, digit 2, digit 3. Hopefully that made sense. And will probably make more sense once we actually draw it. But anyway, we're gonna have our I and our J. We are going to so here's one of the things. So as we go through this, we're creating a tile for each of these column positions and row positions, and that's how we make our entire grid. Now the I and the J are, as I said, like they're the different points in the grid, down and across. But like I said, Lewis starts at 1. And because our screen starts at 0, we want to start at 0. And we're actually going to convert that to do the way that we're used to counting from other languages as, 0 based. So we're going to subtract, so let me show you the tile that we're building. So first we have its I and its J. That's what we've got here, I and J. And then we have the X and Y here, and we have the X and Y that we're about to add here. So the X we're going to want, for the very first one, we're going to want it to be 0, 0. So, of course, this I minus 1 will get you that 0. So we're going to start with that concept. And then likewise, for the other Y, we're going to need that. And then, of course, we're going to need our size, which we get from self.tilesize. I can't spell tile. Tile size, right? So this is 0 and then 0. Now, of course, if we just left it like this, the numbers that we would get for this is, of course, 1, 2, 3, 4, all the way up to 15, and this one is 1 to 20. And then we're just going to subtract 1 from either of those. We don't want those. So subtracting 1 gets a 0 for the first one. That's that. But for the second one, we're going to want it to be at the tile size out here. We want it to move by the size of the tile. So we're going to actually have to multiply this by our tile size to get the X and the Y. Now, like I said, this is how we could just go about calculating these all the time. I mean, like, this object is going to know its size right here, right? It's got its size, so we don't technically need X and Y, because we could just do this math whenever we needed the actual X and Y. But it's not going to change, so that's why we're going to do it up front, save it, and not worry about it. So there you go. That's its X and its Y. Sorry, I should move off screen when need to use a tissue. Anyway, here we go. That creates a tile at each of those locations. Why don't we see that is happening before we move on. So we're gonna get its I. Ooh. We're gonna get its J. Save that. Save the map. What are we missing here? Tile print. let's make sure that everything is working. There we go, we have our map, 2015. Oh yeah, I'm not calling create on that tile, which I wasn't initially going to do, because I just want to show this to you, but we might as well go ahead and do that since we're there. And create it, give it the group. Here you go. And there we go, it's creating all the tiles, as you can see. For each number, like here we'll take 11, and it's 11, it goes all the 11s, 1 to 15 in the J, and then it goes to 12 and does 1 to 15, etc., all the way up until 2015. So there we go, we've created all of our tiles. Now we haven't drawn them on the screen though, so why don't we go ahead and do that now. So what I want to do is just draw rectangles for these. So we're going to go to our old code, check it out, our display rectangle, all this stuff, all this is good and helpful, so let's go ahead and take that, move it over here. Oop, that's not what I meant to do. Comment it all out, or comment it back in, I should say. And so now we have this tile view here. As I said, that was going to come into play. That's what we're actually going to replace character with. Here we go. We have our tile view. So we could reference these all as self.tileView. I like to make just a local variable here, just for ease of programming, cut down on typos. However, at the end of this, we are going to need to set the one on ourself to the tile view that we created here. We also want to insert it into this tile, and this is how it becomes visible. If you'll recall, when we made our game scene, we inserted the background and the character here to add them to the screen, and that's what we're going to be doing here, of course. And that also reminds me that we are going to want to make a background. We'll do that in just a second. But anyway, so here's our tile view. Boom. We're adding it to our group. Everything looks good. We'll just leave the color as is. We're going to set this width to the width that we want it. So yeah, just to make sure you caught what our code was. Pretty simple. We're going to display a new rect that draws a new rectangle. We're going to set the fill color to whatever color this is that we were using before. We're going to set the anchor to the top left, and that'll make it so that it's we set its location based on what we want. Which, as a note, we could put the location here, the X and Y, but we're not going to do that. And the reason we're not going to do that is because our math assumes that we're starting from the top left, and the default for this is the center of the object, and that's not what we want. We want the top left, and therefore we are going to use the top left, and then we are going to set the X and the Y, and that means it'll be based off of where the top left of the object is and not where the center of the object is. At least I hope. I'm trying to remember what we discovered last time. This. Okay, so go to size. We're going to start it at 0, 0, create it at the given size, set the color, move the anchor point to the top left, and then we're going to set its location based on that new anchor point, and then we're going to add it to the screen. Let's save it and see what happens. Hey, it's all there. Now, of course, this could just be one giant block and not a bunch of individual blocks, and how would we know? Good question. In order to prove that, we're going to go ahead and randomize the color. So to do that, I am going to do, this is just For simplicity's sake, math.random will return a number up to whatever number you give it, like between 0 and that number, I believe, or you'd have to look it up. I don't know. Actually, I'll just look it up. Tell you. This is probably good to, share with you also how I look up stuff. Like so one thing that you need to know, and different languages occasionally handle this differently. Most of them, I think, handle it the same. The random value, when you ask for a random number, there we go. When you ask for a random number, they're going to give you a number that is pseudo-random. It's based on, you can get into, it's really interesting if you study it, like how a computer generates a random number, but it's not truly actually random, but it's the best you're going to get. So as you can see, it says it generates a real number between 0 and 1. Now it says between 0 and 1, which would mean that it's not inclusive, which means that it will never return pure 0 or pure 1. I'm not sure that is true. Maybe it is. In other languages, they will include 0 or 1 or not, or etc. Or it might include the 0 but not the 1. I believe that's. Let's go check out math random in JavaScript real quick as a comparison. So it will do 0 inclusive and 1 exclusive, which means it will return 0 or any fraction thereof up to 1, but it will not, because it's exclusive, it will not ever return 1. This says that it's between 0 and 1, but I think that it is the same as JavaScript. I could be wrong. Just seems very odd that it wouldn't actually return 0, but maybe it doesn't. Anyway, as you notice, here's a version of it with an upper as a parameter, which gives the top limit. So this would be 0 and 1. This generates integers between 1 and the upper. Now that's a funny thing, right? Like if you just ask for a random, it's going to give it to you between 0 and 1. If you put an upper, as Lua does, it starts things with a 1 and not a 0. So it's going to start with 1 and give you something between 1 and what your top level number was. And then if you give it both a bottom and a top, it'll give you something between those two. So we're going to create a random number, and then we're going to do a floor to it. And this makes it so that we're not dealing with a bunch of fractions. And so then we're going to do this. So for argument's sake, because this says that it's between 1, it's going to return between 1 and 3, which means it shouldn't return 1 or 3. Now, however, if it returns 1.5, the floor is going to turn it to 1. But that means that it should only return 1 and 2, because it'll never include 3, and the floor of anything else will turn into 1. So theoretically, we should just have 1 and 2 as possibilities. But just for safety's sake, we're going to add an else for any other color, any other one that's not, any other number that's not 1 or 2, just to find out at some point something weird happens and it returns something that we don't expect. So to make this really simple, we're going to just make these red, green, and blue. As I mentioned before, these numbers indicate what color you're using, and they're RGB, red, green, blue. So, If it's all red, zeros, that means it's red, etc., etc. And then we also need to get rid of this one, otherwise it's just going to set it back to the color. There you go. Aha! So, this returns 1, 2, and something that is not 1 or 2. So, I think this document may not be correct because it says between 1 and upper. And that's not right. Now, however, this is, you know, the documentation about what the math library in Lua is supposed to. This is from luausers.org. I don't know what would be the official Lua website. That's probably actually lua.org. Let's go see what they say. Yeah, let's go find out. Math.random. Pseudo random. Turns a number in the range 0 to 1. Now see these bracket in the parentheses refer to inclusive and exclusive. I don't remember which, but I can pretty much guarantee that this does what JavaScript does, where it's going to return 0 all the way up to, but not including 1. And that's why we get the multiple colors. But anyway, bam, tiles. We got our whole tile system. Excellent. We are off to a good start. We've got a bunch of different colored tiles. So that was super fast. As I mentioned, the start of this is going to be a Farmville-esque game. So I'm just trying to think of what I want to do now. We're not going to get into images today. I don't want to do that. So for starters, let's just make them all green, and then let's allow you to select. Let's try to get a menu system going where we are adding in the other items and stuff. So we're going to make them all green for right now. And actually, before I do anything else, you're not going to see any of this. It's not actually going to be useful. Hopefully I won't write any bad code that breaks. But when we call remove self on this guy, we want it to go self.tile. We want to make sure it exists and that we haven't deleted it for some other reason, or we're not calling remove self before it actually was created. But if it exists, it's there, we're going to remove it. Now, remove self is a function that exists on rectangles. So it's there by default. And this allows us, if for whatever reason we have to destroy everything, hey, it's going to go through and destroy this tile. Now we're actually going to go do that for everything else. Now, yeah, so for the map, it needs to go through all of its columns and all of its rows. And for all the there we go. For all the columns in the rows, we're going to remove each tile. And then we're done with that. Of course, so it's going to go through all the columns and all the rows, and it's going to go through here and try to remove all of those. We're going to make sure that the first layer exists. Actually, to make this smarter, why don't we just do this? So, assuming that there is a layer, we are going to go through every eye in that layer's length. Now, Lua does this pound sign for length. So we'll go Lua length, and somebody, there we go. Length operator is this hashtag. Yeah, there's some interesting stuff which this is actually referring to, where this length doesn't return the right thing. That's because this has to be a sequence, and if you have like 1, 2, 3, and then the fourth thing is not there. Like it's you did something silly, like went self.layers 1, and then you went 4, and then you put nil. That will actually break. So when it goes to count, it'll actually stop at this, and so even though there was like a 1, 5, 1, 6, 1, 7, it's not going to count them. So make sure not to throw in nil values in the middle of your arrays, because that will totally screw up everything for you. Anyway, so we're going to do that. And this needs to be, so for every element in that array, we're then going to get all the elements here. And of course, this is going to be our, just going to copy it from over here. We're going to go through and delete them all. Okay. So that should delete everything that's in that. Make sure that they all exist before we go trying to delete them. Of course, like I said, I'm not calling any of this right now. Like technically, we're gonna want this. So here we have game create group. When we destroy our scene, if the game exists, then we want to remove it. Boom. So yeah, theoretically, if our game got destroyed, I would go and remove the map, and then that map would remove all the tiles. If you go to the tiles, all the tiles would remove themselves, and that would be great. Okay, so now we have the sea of green. We're gonna add room for a menu system. I'm gonna do something a little weird here, and then I'm going to try to just use one of their internal widgets for doing items. And the reason for that is it's gonna, we're gonna have a list of items in a Farmville-esque fashion where it's gonna have like different plants that you're then going to plant. We're going to want to be able to select from that list, and then that list is gonna have to scroll and stuff. And let's say that eventually we get into doing actual monetization and store stuff. We're gonna have like all kinds of information there for prices, etc., and there's gonna be more graphics to it. So we're gonna start by just building that out using one of their widgets, but we're gonna have to get some room for it. So let's do this. We were doing width divided by size. Why don't we do this? We're gonna go map width is gonna be the size divided by 5 times 4. So we're gonna leave 1/5 over for our new widget menu. So we're gonna set the width for that, and that should be good. And that should give us room. There we go. Cool. So now we have some room. Now we're gonna go look at our handy dandy Corona SDK API, and let's just go widget. This will take us right to them. There we go. So what we want, I think this scroll view. So now here's the fun part where you get to see how I go about looking through API docs and learning about things and making them work. Now I thought there was something, a widget that had actual tiled elements in it. Maybe that's not true. Let's make sure we're in the APIs. Widgets. Yep, that takes us here. Let's look at segmented control, scroll view. Curious what the picker wheel is, and the slider. and the spinner and the stepper. I wonder if they show examples of these. Okay, here we go. Okay, so this just looks like a sliding, scrolling object. Oh wait, what is this? Segmented control. Let's take a look at what it is. Ooh, interesting. Segmented controls can only be created from image sheets. Image sheets are actually graphics and how we do graphics. I wonder if I should go ahead and show you how to do graphics. What's our picker wheel? Picker wheel is like iOS picker wheel, I think. Oh, a slider is a slider like that. Animated spinner. That's interesting. What's the stepper? Oh, okay. Interesting. Okay. So, you know what we're going to do? We're going to skip that for now. I'll decide what I want to do with that later. We're going to go ahead and just start adding a UI menu. And then from there, we'll have it create plants. Those plants will go onto our grid, and then we will go ahead and take those plants and have them quote-unquote grow, which is to say we'll have different states of them, we'll have them change colors and stuff, and that should be enough work, all those different pieces, to have something done for today. The cat very much wants to help us program, but she cannot because she's no good at typing. So I'm sure you can hear her in the background meowing. Okay, so we have our UI. We're going to give it a width and height. Then we're going to give it an item number. This will be the number of items that we have in it. Let's go item number. And we're going to go item height. That's going to be our height divided by our item number. Let's go ahead and create our initial create function as well. Let's also get a list of items, which we're going to create here. Okay, for now we're just going to do the amount of items that are in the item height. Ooh, not item height. Item number. For the number of items, we're going to create an item, which seems like we need a store item. So we're going to go ahead and make the concept of a store item. Give it its location. Oh yeah. We're going to need an X and a Y to tell our store where we want it to be. As a note, these X and Ys that I include like this, these are the initial X and Y. So like in this tile, this is the initial X and Y. When we create the visual element, we're going to set it here, as we do here, to the X and Y. And that tells it where to draw it. If we then move it, one of the things that we're going to have to do is we're either going to have to update both the X and the Y on this, Or like if we just update the visual element, then this x and y are just the initial x and y. We're going to cross that bridge when we come to it, but that's something to know that, like, of course, because we're not, like, we could just build this visual object and then just add all this stuff to it. That gets a little messy. So instead, I like to have the visual element here, but it means that we have to mirror our x and y over the actual object and then the visual object. So that's just something to know about. So with our items, we have our x and our y. Its x is of course going to be, there we go. Oh yeah, its x is going to be the store's x. That's not going to change. Its y, however, is going to be the store's y plus whatever element it is, -1, so we're back at 0, times the item height. Cool. So this would create us items at these different y locations across here, and there we go. Now we just have to actually go and create those. Our store item. As a note, this needs to have our store item in it. I'm just going to copy this whole thing into the store item. And then we'll fix it up. Okay, right now it's just going to have its x and y. And let's give it a type, which we're going to pass to it momentarily. So what I'm going to do right now is this type is we're going to make a link of that type to the graphics, which in this case are just going to be a color square or whatever, indicating whatever the object is. Later we're going to replace those with actual images of plants and their different growing patterns, but we'll get to that. So for now we're just going to call it item type. And here we go. Store item. Create. This is just like a tile. I'm going to just draw something. Oh yeah, you should know its size. It's good to know. We got its size. We're going to set a fill color for these. I'm going to change this to item view. Probably would be good if I use something consistent for all my objects. Make moving code much easier, and I could just copy paste. However, I don't. So, my bad. And to make this distinguishable, we're just going to make it red. Boom, there we go. Got our store item, blah, we need to know its size, which is, oh, interesting. Okay, so we're actually going to have an X and a Y. So we're going to have width, and then its height is going to be item height. Oh, and then its type. Okay, and what we're going to do for type, I have an idea. For type, we're just going to give it its I value right now. So its type is going to be, 1 to the number of items that we have in the store. and then we're just going to use that number to set its color. Yeah, why don't we do that? Sounds good to me. So we, instead of size, we actually want width and height. Width, height, and down here, width and height. Cool. Now what we're going to do is actually we're going to divide that by this item type, because we know the item type is going to be a number. So that's going to give us a shade, and actually I'm going to make this gray. So we're going to get we should get shades of gray, indicating technically different types. And in order to do that, we want to go add this UI to our game. So we're going to go here, we're going to add the UI. Go down here in our create function and create the UI. Of course, its X is going to be the map's width, and then its height's going to be 0. It's going to start at the, and then its width is going to be, yeah, because we did self width divided by 5 times 4. We're in divide by 5. That's the portion we've left for it width wise, and then height, of course, is going to just be the height of the entire game. Boom. There we go. And the number of items, let's go with 10. There we go. We're gonna now create it. There we go. Got the group. We call our store item. Oh, let's go find out what broke. Bulb game 21. Oh, should probably find out what the deal was. In function create, attempt to call global bulb. Oh yeah. Always include your files. There we go. Now we have a problem in here. Line 16. That should be self.item number. As you can see, there's nothing there. That was because we didn't call our create function, which is what actually draws it and adds it to the group. So let's go ahead and do that. And there we go. We have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's very hard to see the difference between these, kind of almost like a color monitor test. But yeah, these are different items. Good. So now let's go put these different items on the grid. Cool. Yeah, so here's my idea. I'm going to have it where you click one of these, and if you click on the grid somewhere, it's going to place that item. So it'll be this color. And then, as that item technically, quote unquote, grows, it's going to change colors from a shade of gray to a shade of red to a shade of blue to a shade of green to represent different growth states. Eventually, we'll go back and we'll change that with graphics of plants and have the plants growing. But for now, we are just going to use what we have at our disposal. Yeah, my next one will probably be showing you how to do graphics and sprite sheets and etc. Some cool tips on that. But yeah, we'll get to that. So what we want to do is when you touch any of these, so now the question is, how do I want to handle this? There's a couple different ways we can handle this. We can, of course, add touch event listeners to each of these. We could add a touch event listener to the whole thing and then determine that you've clicked one of these. Eventually, this is going to turn into a list that's probably scrollable. So, you know, what location it is and what object it is going to change as this thing gets scrolled. So what we're actually going to do, I think, is we're going to indicate that an item has been touched by doing it here. So we're going to add the event listener to this guy. So let's do this. We're going to do it to self. Technically, item view and self.item view are the same thing here, but I like to, once I've created the self.item view, refer to it by that from then on. So touch. We should be able to do self. Now that should actually call. And this is something that I talked about last time, is that before, when we did this, we called a function. Here's the move block, and this is a function with an event, blah, blah, blah. However, we want access to all the information about this store item. What's actually getting clicked is this store item. It's not just this visual element. And so we want that. So we want to call it on self. Self is this object, and therefore it should call whatever this is, self.touch, the function touch on it, and hey, this is going to be our touch function, which I think this will work. We're going to find out by adding our begin phase. And we're just going to, we can leave that, print what we're printing. Gonna make this destination object so we can set its X and Y and then print it, just so we can have something that we can see. Let's go take a look at this. Yep, see, now if I click these, I get the different numbers and stuff. Now to prove that we can actually get the object information, we're going to print its type. So here we go. Yep, there you go. 1, 2, 3, 4, all the way down to 10. Cool. So we got our different types. That's great. There's a few different things I want to do right now. First, I'm going to make what I pretty much make in all my projects. There's two things that I make that are going to be useful. One is game settings, which I use to handle all the game settings in this game. It's different things like, it's just, I kind of consider this a global that has all the things that I care about in the game. It eventually, like, this is what we'll talk to for saving, it's what we're going to talk to for, like, in this case, it's going to have our information on what types mean and what happens when we use those different types. So you'll see. Let's just go ahead and create it. It'll make more sense as I go. So we're going to want to make a base class, which if you remember how to write this, you can write it. If not, you could just copy and paste from one of our other versions of it. Oops. Like everything else, we're going to have this bulk game settings, and it's going to have a create. Well, no, technically it won't have a create, because this is then actually going to get shown on screen. I'm eventually going to show you how to save data, and that's what this setup from data is going to be. So, for instance, this is going to have all kind of like the base game knowledge. For instance, it'll have probably the actual map. So when we save, and this does a setup from data, it's actually going to set up the map for us. But for right now, let's just act like this doesn't exist. We've just got our game settings, and what I wanted here is to make a map of types. And here, what we're going to do is this. We're going to make up types here. So we know there are going to be 10 types. I'm going to use this to make what those types are. This is all going to become very different later. I'm probably going to load this stuff from files, and we're probably going to generate that somehow. But for now, just going to do it manually. I'm just looking up Lua's object instantiation so that I know what I can do. Yeah, as a note to show you what I'm looking up. I was just looking up Lua, or instantiate an object in Lua, because I was trying to remember this syntax. So here you create balance equals 0, and I think it's comma for any other objects or parameters. So what I want is to do this, like so. We're gonna go tile name. I'm just gonna make it simple on myself. Column 1, and then let's see, not color. Let's put cost in here. Let's go 1001. And so now we're gonna put this on all of these. I'm gonna do this manually. And we're gonna test that I wrote this actually correctly, because I don't remember. Not often creating objects like this. There we go. You will see shortly why we want to do this. Okay, so like I said, this is kind of global. I want it accessible everywhere, which is why I added here. And it's called in other languages you call it a singleton. This is not a singleton because I could make multiples of these. But that being said, I'm not going to. I am going to only have one that is accessible from everywhere. Because I'm never going to need more than the one. Yeah, we're going to call it bulk game settings. See, and here's where it would become problematic, or it often becomes problematic in other games that I've made when I didn't name these things like, hey, this is bulb game settings, is that, I'm making this global, and so everything can refer to it, and if that conflicted with the game settings of another game, we would have problems. So, anyway, that's what we have. Bulb game settings, basic stuff. Oh yeah. There's types equals the types. It's all good. So let's go here. When we actually print our item, I'm gonna do this. So game settings, bulb game settings is accessible from everywhere. Because it's here in main outside of any other context. So if we do types and then we do self.item type, and then we do item name, should get its name, and we can take this whole thing. We can get its color as well. Or not color, what did I say? Cost. Make sure I called those things right. Tile name, cost. I think I put item here. Cool. Let's see if that worked for us. Nope. What do we break? Of course, it's here on 31. Attempt to index global bulb game settings, a nil value. Interesting. Oh. Yeah, I don't want this to be local. I want it to be global. Hopefully I named it correctly. Yep, there you go. So you can see if I click 10, you get its name, its cost, etc. So now that's accessible anywhere. So now, what do we want to do? We want to add states to our game. All right, so we're gonna create a state. I'm gonna call this nothing for now. I don't know yet what we're gonna call it, but when you click on one of these things, we're gonna go into the quote-unquote planting state where you plant them, and then we'll see what happens from there. So let's do that. Okay. So we're going to put a function on here for finding out when you've planted something. Here is planting. Actually, here, we're going to say set planting, and then we're going to go plant type. We're going to print this. Okay, so now we have a function for plant type. We're going to tell bulb UI that's what we want it to do when planting. And now eventually I'm going to get into fancy things like we're going to do our own versions of kind of events. I'm not going to add that right now. Just because this is pretty simple and there's nothing else is going to be listening on this, so it's going to make it simpler if I just do it this way. So we're going to go self.setPlanting. No, what we want is this, I believe. Planting, because we're going to pass this function, this entire function, to here. And now this is where I'm trying to remember. I believe this works. We'll see if it doesn't. It's been a long time. We're going to call this planting function. Do this. Planting function equals planting function. And when we do touch, we're going to go self.planting function with this. Let's see if that worked. Nope. This is an item. The item needs it from the UI, of course. So we're going to go planting function. Planting function equals the planting function. Now we're going to pass it to our tiles. Planting function. else we got? Still a nil value. When we call it here, 33, self.planting function. That's planting function, store item, self.planting function. Yes, okay, I think that we might have to do this. Oh, got something different. Concatenate plant type. Can't concatenate plant type. That must mean plant type was null value. Why was it a null value? Attempt to concatenate local plant type. That happened after we did this. Self.item type does exist. I think this is optimal if I end every stream with somewhere that I have gotten messed up. Let's see. Self-sub planning function. Actually, I have no good reason why that is, but you know what I'm gonna do? I'm gonna actually show you events because we got like 20 minutes before I end this stream, and I think it would be better to just do it that way. So what we're going to do is we're going to add an event listener. Now these are going to become our own types of adding event listeners. Actually, I want to see something. I'm just looking up dispatching events to find out if Corona actually has a built-in event listener system. Event to object. So, of course, let me show you what I'm looking at. Just searched Corona SDK dispatch event. Yeah, Corona gives you your own way of doing custom events, which might be nice, so we don't have to write our own. So it looks like you can just do a simple add event listener, my event, and the listener, and the type, dispatches of specified event, the event parameter, string, blah blah blah. In Corona, you can register custom events. Now, can I not create an object with the listener? Because that's what I ideally want. But yeah, why don't we just use theirs, and we'll see how this works. So we're just going to add an event listener. Let's test this out because I haven't used this before. So we're going to make this test listener. And first thing we're going to do is just print that it worked. And we're going to add an event listener. Create, yeah, of course. This needs to be, we're going to give it, what are we going to call this? Select plant. That's a great event name, and it needs a listener, of course. So we're going to give it the test listener. There we go. Attempt to call method, add event listener, no value. Let me see something. Image. Oh, so yeah, so you can add it. It's on no, so it's on image. Let's go look at the custom events thing. Maybe there's more that we need to do. They're just telling you how to use events that already exist. Dispatching an event. We have this event that we want to dispatch. Dispatch event. That's great. How do we listen to it? Okay, we have our listener. Why does this site look messed up? Blah blah blah. So player out of that listener. This is events. What I can't figure out is what built-in events. Once you have an event table set up, you can call. Let's say start a game with player's health would be 75. It's a med pack at 100%. This time, dispatch a health event. So the first thing you need to do is create an event table that will have all the data you want to set the listener function. More on that later. Oh, you know what? Maybe you have to create this event with a name in order for Corona to set up the whole add event listener thing. So let's go find out about that. Here, we're gonna try it here. Huh. It's local to it. Huh. Interesting. Okay, so we're gonna follow this function and we're gonna try it ourselves like this. C dot event. We're gonna call this. Oh yeah. So we're not gonna do this planting function stuff. Let's get rid of that. Da, 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 da. We're gonna go ahead and do plant event equals an object. Name equals select plant. Test equals data. We're just going to throw some test data on there. And then what we're going to do is this. Self. Actually, so let's take this plant event that we've got here. Get rid of that garbage. Go down here. Here's our plant event. And we're going to dispatch plant event. Now, I'm curious as if that actually makes the difference. I don't think so, though. But we got broken code. What do we got? Plant UI 23. Oh, we need a comma here. Also gonna add spaces. So this is visible. Boom. Okay. Attempt to call add event listener nil value. Add event listener. Okay. Name key in the event table is passed to the object dispatch event method. One is required. The rest are completely custom. For the sake of being thorough, here's how you dispatch a health event when the user health level is low and empty. Okay, great. Having objects listening. Exactly the same as having them listen for any of Corona's predefined events. Simply specify the event name, the same one specified when you dispatch the event, the function to be called when that type of event is received. See, what I want to know is when he says player, what is player? Is it just an object? If it is, Why does this not work for us? In the following example, you can have a reference to the object, a self-object. Add event listener. Yeah, see, add event listener health player. Yeah, that all looks great. That looks exactly like how their add event listeners work. As you go along, here are some things. Contrast with the built-in, you must control which events are dispatched. Unless you're listening. Table objects. It requires a name key. Call function instead of dispatching an event. The primary benefit of using events is that you can simply have certain objects stop listening to events whenever you want. Blah blah. A bunch of Boolean variables. Using events also arguably promotes cleaner coding practices. What kind of creative custom ways have you utilized Corona's custom event model? None, because their custom event model is not working for me. Let's go find out. So again, this is part of the process. Is I actually am not just going to teach you how this works. I want you to see the process I go through when I'm trying to learn something and debug stuff. So here we go. We're actually attempt call method add event listener nil value. We're going to search that. Oftentimes error code is great to search because see, even without mentioning Corona, we're going to get those because that is the specific code. Let's see if they could say nope, they're using physics bodies. I want to see if this actually works. Registering event listeners. Make sure this looks like our example. Basic interactivity and event detection. That's listening to the object's list of listeners when the event occurs. Event name listener. Looks pretty similar. Make sure I didn't spell anything wrong. Yep, still broken. Yeah, what I want to know is if they actually allow you to do that or you have to implement yourself, but it looks like you can. See, all of their examples use an object that is one of their objects. One of their objects obviously has an event listener. This says custom anywhere. Nope, no custom. We're gonna add custom event because we want when people are not not using the base objects. We want to make our own objects. Yeah, an event listener. Is that what this person is doing? Yeah, see, here we go. They got their object and the other object. Dispatch event. Blah, blah, blah. Great. Huh, why does it say runtime add event listeners only black runtime and objects created. It's updating my code to include new image calls. Yeah, see, now this is interesting because Corona, this custom event makes it sound like you can add the add event listener to anything, but that does not seem to be true. We're gonna go through this. SDK, custom event. Take a look at this. Creating class and dispatching events from it. Explained here, the dispatch event is a method of a display object. So you can't call it on your class because class is just a table representing a class. You should probably name it something else. So you would call dispatch event on rect. Yeah, this is interesting. So it seems like you only dispatch it off of an object, but that's not what this says. It doesn't seem. See a single object player, but it doesn't say display object. Okay. Well, I know a clever hack for this. Okay, so you can only do it to a display object, so we're gonna hack around this for right now, and we're gonna fix it up later. So we're gonna give Bulb UI its own add event listener, and all of that is going to do actually, we're just going to manually create this. That's fine. Yeah. Okay. We're just totally going to manually do this. I'm probably going to show a better way to do this later, but for now, we're going to try to just brute force it. So, events is our list. We are going to, this is how you do adding something to the end of a list, is so you take the length of this, or our events list. We're going to take the length and add 1, so it puts the next one in the order, and then we're going to set that to something, and that something that we're going to set it to is this. Actually, no, what we're going to do is we're going to do it by type first. We're going to go type, and if this is not there, so what this does is it says if events type doesn't exist, then do something, and that something that we're going to do is we're actually going to create it. So we're going to go self.events type, and we're going to set that to a new object, and then that object we're going to treat like a list. and we're going to put in an item. So we're actually going to need the length of this. So that's actually what I was just showing. So you do the hashtag the length, add 1, and now the next thing that we're going to add in there is this object. Cool. So now we've added that object, and now that has added the event listener. Now we're going to have to do the same thing in our store item. Yeah, I might go modify this class function to have, so instead of add event listener, etc. Maybe that's a good idea. Maybe it's not. We'll see. Okay, boom. Just copy the whole thing over, and here we go. Now this has events and it has event listeners. And so now what we're going to do is make a dispatch event for this guy. We're going to give a type. We're going to give data. And what this is going to do is it's going to, for I equals 1, self.events type. First off, let's make sure that that even exists. So as long as events type exists, we're going to iterate through it. And we're going to go self.events type object. We're going to say handle event. Oh, interesting. I wonder if the problem this had was because we're creating an object, and this player object needs to handle that event. Now the player object, how does it handle the event? Where is our player? Event listener, health listener. Using a table listener, as soon as the following symbol, you can reference the object with self. So we have player health equals health listener. Oh, okay. Okay, let's try that out real quick. Before we get too far into this, get rid of all this stuff. Let's save it. Continue, see if we still get our error, which should just be close our game at 28. Where we added listeners select plant. So this actually self UI. No, what we want is self. Add event listener select plant. Huh. I have no idea if this will work. In the next stream, I will probably play around with this a lot more and give you some better info. That's the fun of being here on the stream, is finding out things that do and don't work and understanding how I go about doing this. I'm still writing things in the totally wrong way. Okay, so if we had a select plant, maybe that's what it wants. 32. Nope, no value. Oh yeah, we don't even need that. We're not, yeah, never mind. Never mind, I'm going crazy. Let's not do that. Add event listener. Attempt to call method add event listener. A nil value add event listeners. Yes, let's put it back in here. Now event listener is not a nil value. That's the problem 126. Oh yes, this is calling dispatch event, which doesn't that's fine. So let's go here. So we've got our event listener. Types, blah blah. We go through all of our types. We do need to end this. And end this. We handle event. Oh, you know what? We want to go type. No, how do we do that? I am searching this, trying to turn a Lua string to a function name. I believe we can just do it like this. Yeah, see, calls a function. Yeah, we're gonna find out if that works. So imagine it's this, and we're gonna put in type and try calling it, which would mean, oh, this is all kinds of weird because we're just trying to pass it along. I'm not exactly sure how I want to do that. Okay, so let's say this is actually how this worked. Let's start here. Let's get rid of all of this. I'm just going to do it on this side, on the UI. We're going to dispatch an event, given the type, plant event. Okay, so dispatch event, we're going to do data. So it means data.name. What the name of the function is that we're going to call on that object. I wonder if that actually works. We're loading that module. Wait. Alright. Let's figure out what we did wrong. Okay, first off, parentheses are all or nothing. Can't halfway do them. Okay, fascinating. No errors. Okay, now we're getting somewhere. 34, attempt to call planting function, nil value, 34. In here, so planting function, that's fine. Okay, so here's what we wanted to do. We want to test this. So to the UI, we add an event listener, select plant. So let's just show that we did that. Okay, good. As you can see here, we got the type. That means that we're trying to do that. That's good. Now, we events type. Type doesn't even exist, so here. So we're gonna do this. Say created type, so we know that it exists. Yep, created the type. That's good. Now, Oh, okay. We're trying to do this thing where we're going to take the name and we dispatch the event and call that event name on the object, this object. So in order for that to work, we are going to actually have to follow that over here, which means we're going to have to pass the self, and then we're going to have a function on this called select plant underscore. That's terrible naming. Do not want to do that. But let's go like this. Print. Something's happening. Okay. Okay, nothing happened. So let's see. Let's see if we're calling this. Oh yes, there's no type here, of course. We've replaced type with data.name. There we go. Dispatching data.name. There we go. Look, it dispatched something, and there we go. Okay, so we're gonna stop there for today. I'm gonna show you other stuff with events later. Maybe we'll add it to our base class, get really fancy. But what we did here, just as a quick explainer, we actually get rid of this test function, not using it. So eventually what we're going to want is we're going to want to be able to dispatch events from these store items and have them get handled on the UI. And actually what we're probably going to do is dispatch them from here, and then this UI is going to dispatch them. And then the game is going to say, hey, like it wants to listen to when you have selected a plant, because then it's going to change the game mode to the planting mode. What we did currently is we mirrored the way that Corona does their thing. So they give an event name. That event name corresponds to a function on the object. So because we're using this self object, this whole thing, it's going to be this function name. And when you add an event listener, when it gets dispatched, it's going to trigger this function. And how we did that is we created a list of event listeners. We have to give them a type because we might want to have select plant. We also might want to have like deselect plant. And so that would be a different type. So this creates a list of listeners for that type. And then it adds this object to that listener. And then what we did is we made our handy dandy dispatch function, which takes in the data, data like this. And then given that the name of the function, it goes looks that up in events, right? So this was a select plant event, and this is a select plant event. So it goes looks that up in events. Then it goes through all of the listeners for that event, and it says like, hey, given that listener, there we go, in that list, call a function with data.name. Data.name, of course, is select plant, so it's going to call the select plant function, which is this function. And then it's going to call it with this data, which is this data, which actually, it's we're going to put that in there, and this will prove it, is that we go data.test, and voila, it's broken. Is test a null value? Let's find out. That might be bad. A null value, it is a null value. So why did this not work? We're going to go print data. Runtime error. Dispatching print data. Well, that doesn't make a whole lot of sense. I wonder if we are messing. Well, no, see, dispatching, we have the name. Put data.test. I'm very curious now. Things have gotten very interesting. What if we didn't have a dispatch function? Bulb UI, attempt to index local value, data, and nil value on line 29. What is it talking about? Oh, I'm looking at the wrong thing because I'm not scrolled all the way down. Attempt to call dispatch event, nil value. Okay, that's fine. Yeah, make sure you're scrolled down, kids. Know that you're looking at the right thing. Attempt to index local data, a nil value. That doesn't make any sense. Because we're using data.name. It says build game. Oh, here we go, 29. Oh, that's fine. Here, data.test. I'm just gonna put data. What I care about is, yes, that's a nil. Okay, yeah, so data.test says winning. So when I call that function, why am I not calling it with data? I wonder, is data the second thing? Maybe this is self and then it's data. Good question. I'm not entirely sure what's happening there. So this should be, when you're calling this function, should be passing that data, but it's not, which is fascinating. But that's the end of our stream. We're gonna figure that out next week, figure out why this data is not being passed in this event, and then we're probably gonna change up how events are handled regardless. Figure out a different system. Like I said, I like to end on something totally breaking. So here we go. We're gonna leave it here, where at least it's hitting our function. It's not passing the data we want to pass. Let's try that. We're gonna go like this, if data, so that it doesn't break. It just says there's no data. Okay, no data. Yep, I don't know why that's not passing, but we'll figure that out next week. Anyway, I hope you have learned something. Remember, check out TylerMakes.com or check me out on Twitter to see when I'm streaming. This should be most Fridays. It was a little late this week. It'll be better next week. Also, check out my GitHub, which is just TylerMakes/Bulbasaur. For this project, I'm going to push this up to Git so that you can get access to it. All right, have a great week. Oh, also check out my stream and my YouTube for all the other things that I do. I have like a vlog that I put up. It should be Mondays, where I talk about things like this and what I'm doing. And then I also post Twitch highlights and I stream games on Thursdays. And yeah, I'll get better at this once I've got the spiel down. But yeah, just check out TylerMakes.com. Oh, that's what I was gonna say. I'm also running experiments on Twitch when I'm not explaining how to make games or playing a game. And those experiments involve the chat interacting with a live game that's streaming, a la Twitch Plays Pokemon. So go, check out the stream periodically, specifically on Thursdays and Fridays when I'm usually running something. Yeah, that's it. Have a great week.